friends, and welcome to WikipediaWorld.com, your destination to online education. Friends, today we are going to start with a very new section of periodic table with Dobereiner's Triads. So in this section, we'll be learning about the history of the periodic table, that is to introduction to the periodic table. We'll learn more about chemist J.W. Dobereiner, and we'll be discussing the Dobereiner's Triads law with help of some examples. And lastly, we'll know the drawbacks of Dobereiner's Triad law. So friends, before starting with the sections, if we ask you one question, what will you do if I give you two different rooms? That is, if I give you two different unmanaged, untidy rooms. First, with the distorted books in it, and second, with all untidy and unkept room. What will you do? As it is a human instinct to classify, you'll surely be putting the things of one kind in one lot and of another kind in another lot. Similarly, in terms of chemistry, we'll learn the classification of elements, right? First, we know that we have around 115 elements discovered, right? So it is very difficult to study the properties of all these elements separately, right? So there's a need of classifying the elements. Let's talk about the reasons to classify the elements. First, as it helps us to study the element in an organized manner. It also helps to correlate the properties of the element with the fundamental properties of all the states of matter. And lastly, it helps us to define the relationship of one element with another. As friends, in beginning, attempts were made by chemists to classify elements on the basis of many physical properties, such as these are the properties based on which the elements were classified: density, malleability, ductility, and many more, and also considering whether they were metals or non-metals, right? But none of these early classification proves this satisfactory because the number element falling in a particular group was so large that it did not serve the purpose of generalization, or some of the characteristics being considered vary under different conditions. Also, the certain elements showed a metallic as well as a non-metallic characters. So what and how the classification has generated? Yes. Now the history starts. As friends, before written history, people were aware of some of the elements like gold, silver, copper, lead, tin, mercury, etc. It wasn't until 1649, however, until the first element was discovered through a scientific inquiry. Who was that person? It was Henning Brand. He actually discovered phosphorus. So by 1869, 63 elements were discovered. This is a part of a discovery, but if I talk about the classification, it was William Prout. Let's write down William Prout in 1815, who discovered atomic mass which does not vary of a particular element. Let's write down discovery of atomic mass of an element which never varied, right? And thus that it could therefore form the truly scientific basis for a satisfactory scheme of classification. Now, as we have the atomic mass which never varies, between 1817 to 1829, we have Johann Dobereiner, who began to group the element with a similar property into groups of three, or call it triads. Right? That is, we can write element grouped with similar chemical property of 3, right? Now after the Johann Dobereiner begins to grouping of the elements into 3, Day is the precursor to the periodic table, that is in 1862 A.E. Beguier was the first person to make use of atomic weights to reveal that the elements were arranged according to the atomic weights, with similar elements occurring at regular intervals. So if we write the person to make use of atomic weights, right? After he introduced atomic weights in 1863, John Newland, an English chemist, proposed the law of octave. He proposed law of octaves, which state that elements repeated their chemical property every eighth element. After the analogy, which ridiculed at that time but was found to be insightful after the work of Mendeleev and Mayers were published, that is, the father of the periodic table is Lothar Mayer, and Dmitry Ivanovich Mendeleev independently produced remarkably similar version of periodic tables of element at the essentially the same time. Mayers in 1864 and 1870 with the Mendeleev periodic table. So friends, after they produced the periodic table, Mendeleev and Lothar Mayer, Glenn Seaborg, who discovered the transuranium element with the atomic weight 94 to 102. The completion of the actinide series allowed Seaborg to redesign the periodic table into its current form. Both the lanthanide and actinide series of elements were placed under the rest of the periodic table. These elements technically should be placed between the alkaline earth metals and transition metals. However, since this would make the periodic table too wide, they were placed below the rest of the elements. So Glenn have discovered actinide and lanthanide series, which actually created modern periodic table. His was 1864 and his is 1817. So this is actually the flowchart of the history of the elements, that is the classification of the elements. So friends, let's understand now or brief out the introduction. first is that in 1649 the first element was discovered by Henning Brand, and the element was phosphorus. In 1815 William Prout discovered the atomic mass of an element which never varied. And in 1869, 63 elements were discovered. So, by the midst of 18th to 19th century, elements became to discover and with their chemical properties. So many scientists, so many chemists have given their inputs to form the periodic table. Now we call it the modern periodic table. So we shall learn all these renewation of the periodic table in our future slides and sections. So in this section, let's understand the Dobereiner's triads. But before starting with the law, let's understand and know something about the chemist J.W. Dobereiner, whose full name is Johann Wolfgang Dobereiner. He was a German chemist born in Germany in December 13, 1780. He discovered the Dobereiner law of triads. According to him, certain elements displayed similar chemical property and could be put together in the group of 3 elements each. So he grouped these 3 elements each and called these group as a triads. As all these 3 elements of a particular triad has a similar chemical property. In fact, the Dobereiner was the first scientist to show the clean relationship between the property of an element and its atomic mass. So let's start now the law, which says when elements are arranged in the order of increasing atomic mass, group of 3 elements, we call it triad, having similar chemical property are obtained. The atomic mass of the middle element of the triad being equal to the arithmetic mean of atomic masses of the other 2 elements. This point will become more clear from the examples which I am going to discuss with you. So let's start with the alkali metal group. Friends, let's write down all these chemical properties they are sharing with. So all these elements are metal, right? Secondly, all of them react with water to form alkalis and hydrogen gas. Third, all of them have a valency of 1, so they can call monovalent, right? So friends, according to the law from the upper table, we can see that the lithium is the first element, This is the third element, and this is the middle one, right? So from this table, it is clear that the lithium is the first element of the triad and sodium is the middle element, and whereas potassium is the third element of the triad. Now let's understand the law, that is atomic mass of lithium is 7, atomic mass of potassium is 39. So according to the law, the arithmetic mean of the atomic masses of first and third will be 7 plus 39 by 2 comes out to be 46 by 2, that is 23. And the actual mass, that is actual atomic mass of sodium is also 23. So from this calculation, we find that the arithmetic mean of the atomic masses of lithium and potassium is 23, which is equal to the actual atomic mass of the middle element of the triad, which is sodium. Thus, the atomic mass of the middle element of the triad is equal to the arithmetic mean of the atomic masses of first and third element. Please friends, note that the lithium, sodium and potassium are called alkali metal group because they form alkalis which we can caustic solution on reaction with water. So now come up to the second example, which is alkaline earth metal group, where you can see elements like calcium, strontium and barium having a similar chemical property and form a triad. So what is these chemical property they are sharing with each other? First is they are metals, right? The oxides of all of them are alkalines in nature. Third, they all have valency of 2, that is they are divalent, right? Now friends, according to the law, the atomic mass of the first element is calcium, which is 40. So the atomic mass of the third element is 137. So taking the arithmetic mean of these atomic masses, which is 40 plus 137 upon 2, which comes out to be 88.5, and the actual atomic mass of strontium is 88. You can see the similarity. Thus, the atomic mass of the middle element of the triad, strontium, is approximately equal to the arithmetic mean of the atomic mass of the first and third element. So now friends, please note that these three elements are called alkaline, earth, metal because their oxides are alkaline in nature, which actually exist in the earth. So we call them alkaline earth, and hence these are metals, so we call them alkaline earth metals. Coming up to the last example, halogen group. We have here chlorine, bromine and iodine. Includes a triad with the chemical property as they are all nonmetals. They react with water to form acid. Thirdly, they have a valency of 1, that is they are monovalent, right? So according to the triad law, the atomic mass of chlorine is 35.5. The atomic mass of iodine, the third element, is 127. So if we take out the arithmetic mean of the atomic masses of first and third, that is 35.5 plus 127 by 2, which comes out to be 81.2. And the actual atomic mass of bromine, be the middlemost element, is 80. Thus, the atomic mass of the middle element of the triad bromine is approximately equal to the arithmetic mean of the atomic masses of first and third elements of the triad, that is chlorine and iodine. So friends, please note here also that these three elements, we call them halogen group. Why? Because they form salts, that is they react with metals to form salts. Halo means salt, gen means producer. So friends, we have understood the Dobereiner's triad law. With help of some examples, we took the halogen group, the alkaline earth metal group and the alkali metal group. I hope you have understood now, but let's now understand the drawbacks of the Dobereiner's triads law. That is, the law failed to arrange all the then known elements in form of triads, and it also failed to apply all this law into the same family. For example, in halogen, if we consider the first three elements, that is first three members like fluorine 19, chlorine 35.5, N-bromine 80, it could be observed that the mean of the atomic masses of fluorine and bromine will be 49.5 and 35.5. So the scheme of classification of elements was not very successful, even though it contained important insights and principles. To overcome this failure, in 1864, John Newlands arranged the elements in the ascending order of their atomic masses and found that every eighth element had properties similar to the properties of the first element. We shall be discussing in the next session, but before ending up, I shall give you one small activity. That is, I have asked you A, B, C are the elements of Dobereiner's triad. If the atomic mass of A is 7 and that of C is 39, what should be the atomic mass of B? It is a very simple question. So let's meet in the next session with the Newlands law of octaves. Thank you. Thank you for watching Edupedia World videos.